Hi everyone, my name is Chen Yizhu, and welcome to my presentation on responsible AI in this video. I will walk through my approach to developing a fair and transparent machine learning model. This project involves applying responsible AI principles to classification task using light GBM, ensuring fairness, ethical consideration, and clear decision-making explanations. I will cover the dataset, processing steps, model training, fairness assessment, and explainability techniques, ensuring that we align with best practice in ethical AI. So first, let's talk about the understanding of the dataset. So before building the model, I conduct an in-depth exploration of the dataset. This included checking for missing values and applying appropriate imputation techniques. Performing an exploratory data analysis to understand the feature distribution, correlation, and potential bias. Identifying class imbalances and addressing them through data resembling techniques. So that's a key challenge was handling missing data. For numerical features, I use the median for imputation, while for categorical features, I apply the most frequent category. And second, let's talk about feature engineering and processing. To improve model performance and fairness, I apply several processing techniques. The first is encoding categorical variables. I use one-hot encoder for nominal features and ordinary encoder for ordinary ones. The second, feature scaling, standardizing numerical feature using standard scaler to ensure consistent magnitudes. Third, creating new features. Some domain-specific engineered feature were added to enhance prediction power. And the fourth is addressing class imbalance. Since the dataset exhibit skewed class distribution, I apply SMOT to generate synthetic samples for underrepresented categories. Third, let's talk about model selection and training process. I experiment with multiple models, including like GBM, XGBoost, and the random forest classifier. To ensure a well-generalized model, I implemented cross-validation using Starfire K-fold to evaluate performance across different data splits. The model will compare using accuracy, precision, recall, F1 score, AUC, ROC, and log loss. And for the hyperparameter tuning was performed using Gorilla Search CV to optimize model parameters. The best performing model was Light GBM, selected for its balance of efficiency and clarity. Fairness and bias evaluation. Ensuring fairness was a crucial aspect of this project. I apply multiple fairness metrics, crucial such as demographic parties, ensuring that predictions are proportionally distributed across different demographic groups. And also like equalize odds, checking the mode has similar accuracy rates across different subgroups. And also bias detection, identifying whether certain groups have systematically higher misclassification rates. And the fourth is post-processing fairness adjustment, modifying prediction to mitigate disparities while preserving performance. To address fairness, I analyze how models' prediction differ across sensitive attributes. Adjustments were made where necessary to improve overall equity in decision-making. Fifth, let's talk about enhancing model transparency. Understanding how and why a model makes prediction is essential for responsible AI. To improve the transparency, I used sharp values allow me to identify which feature contributed most individual predictions and overall model behavior. And for Lime was used to generate interpretable explanations for specific prediction. Counterfactual explanations. They were employed to see how small changes in post features would impact prediction, ensuring the model consistency and fairness. And the last is confusion matrix analysis. I examine false positive and false negative to understand model weakness and bias. By incorporating those tools, I was able to provide both global and local explanation, ensuring the model decisions are transparent and interpretable to stakeholders. And six, let's talk about ethical consideration in AI beyond fairness and transparency. AI must be trustworthy and accountable. I address several ethical concerns, including transparency. By implementing SHARP and Line, I ensure that user could interpret and trust model predictions. Accountability, I provide mechanisms to audit and improve the model in case unfair bias was detected. Trustworthiness, the model was rigorously tested across different subgroups to ensure consistency. So there's a key takeaway from this ethical analysis was the importance of continuous model monitoring. Bias may evolve over time, so it's critical to reassess fairness metrics particularly. And last, the conclusion and final thoughts. In summary, this project successfully incorporated responsible AI principles into machine learning model. Key takeaways including using fairness metrics to identify and across potential bias, apply sharp, line, and counterfactual analysis for clear, actionable explanation, ensuring transparency and accountability through ethical AI practice. By integrating these techniques, I built a model that is not only accurate, but also fair, interpretable, and ethical. This project highlights how machine learning can be powerful and responsible when designed with this. Thank you for watching.